Good morning. Today we're going to see about the problems with the concepts of supports and loads. Here, in this image, we'll able to see clearly that there are two beams that is of AB and CD are shown in the figure. A and D are hinged supports, B and C are roller supports. From the figure, at the point A, we are having a hinge support. We'll able to see the supports at point A. It is a hinged support, and at point B, it is also a hinged support, and at point B, it is also a hinged support. Whereas in the point C, it is a roller support. Initially, we have to draw a free body diagram for these beams. We have to draw two separate free body diagrams for A, B beam, and for beam C and D. For both the beams, we have to draw free body diagrams. Then we have to identify the reaction force that supports A and B, the reaction force that supports C and D. Let's see how we have to draw the free body diagram. Let's draw the free body diagram of A first. It is beam AB. At point A, since it is a hinged support, we'll have a one vertical reaction force VA, then one horizontal reaction force HA. Then we have to resolve this force, inclination force, which is traveling towards the third quadrant to the horizontal. Horizontal is 30 cos 60, and vertical it is downwards 30 sin 60. 30 sin 60. And here a roller support. We have to consider this roller support acts in the downward direction. For roller support, where there is only one reaction force, it is perpendicular to the roller support. Here once again a hinged support, VB upward direction. We are assuming that VB in the upward direction, and HB in the left side. HB. These are our assumptions. Likewise, we have to draw free body diagram for CD. For since we are assumed the downward direction RC over here, in the downward direction, here we have to assume in the upward direction RC. Then this uniformly distributed load need to be converted into point load. For converting this into point load, we have to multiply this 2 meter into 10. 2 into 10. This 2 into 10 is 20 kilonewton. This 20 kilonewton acts midpoint of the portion which it covers. So for in the 2 meter, it will cover up to 1 meter from the left hand side. So it is 1 meter over here. It is also in the downward direction. Again for D, there will be two reaction force, VD and HD. The distance from point C to the reaction force, that is the UDL force, which is we have converted into a point load, is of 4 meter. We have to consider this acts at 4 meter from this part. 4 meter, that is 4 meter. This 2 is divided by 1 by 2 into 2. We have drawn the free body diagram. After drawing the free body diagram, then we have to consider either we have to draw the first, we have to identify the for the beam AB or beam CD. Let us go with beam CD because there is only very minimal number of unknowns that in the beam CD. So we will take beam CD to first. This is the free body diagram. And here it is beam CD, which we have drawn the above. First, we have to consider beam CD. For beam CD, since the systems in are with the supports, we have to assume sigma Fh is equal to 0, sigma Fe is equal to 0, sigma R is equal to 0, and moment about a point is equal to 0. Here, the horizontal force is acting towards the left side. That is only one force. We have taken it as a sigma, HD. And therefore, HD is equal to 0. So now that we need not need to be show that. Here it is given sigma Fx is equal to 0. Sigma Fx is only HD force. Likewise, sigma Fy. For sigma Fy, two forces are acting upward directions, RC and RD. It is given here. RC and RD is given here. RC and RD is acting upward directions, RC and RD. These two forces are acting in upward direction. RC and RD. It is acting on the upward direction. So RC plus RD, this 20 kilonewton acts downward direction is minus 20. So RC plus RD is equal to 20 Newton. Let us take it as equation 1. Then we have to identify the moment for this equation. Let it be moment about C. Moment about C. When we find moment about C, this 20 kilonewton is on the clockwise direction. So clockwise direction, we have to consider it as minus. So 20 into 4. 20 into 4 plus, then here we are horizontal force acts along the axis line. So we need not consider this force because the perpendicular distance is 0. So we have to take this distance, this reaction force. Here, this reaction force RD, that is, we have taken it as a VD into, here they have given it as RDY into perpendicular distance towards C is 4 plus 3, 7. So RD into 7, RDY into 7. So by solving this, we'll get RDY as 11.43 kilonewton. Then we have to substitute this 11.4 kilonewton in the above equation to find the RC. So RDY value is 11.43 kilonewton. By substituting this, we will get the RC value as 8.57 kilonewton. Then now we have to take the another beam for solving and identifying the unknown forces. Here also we have to write down the equation for sigma Fx. Sigma Fx is equal to 0. Here sigma Fx is RAX acting towards the right hand side, so plus RAX, and then we have to consider the resolved force which we have resolved on the left hand side. So 30 cos 60, it is on the left hand side, it is minus RAX minus 30 cos 60 is equal to 0. Therefore, RAX is equal to 15 kilonewton. Similarly, to identify sigma Fy, all the vertical forces taken to considerations, RAY plus RC plus RD minus 30 sin 60 is equal to 0. We know the value of RC. We substitute the RC value. It is a minus, since it acts in the downward direction, it is minus 8.57. So we'll get RA Y plus RB is equal to 34.5. We have to identify the moment. Sigma MA is equal to 0. Here sigma MA for at the two forces are acting at the point A, so that will become 0 since the perpendicular distance is 0. Similarly, the horizontal force also will become 0. So we have to take only the vertical forces. 30 sin 60, it is on the clockwise direction. So minus 30 sin 60, the perpendicular distance is 2. Then RC value is 8.57. It is also in the clockwise direction. So RC 8.57 into the perpendicular distance is 2 plus 3, 5 meter. Then RD is on the anti-clockwise direction plus RD, the perpendicular distance is 2 plus 3 plus 3, 8 meter. By solving this equation, we'll get the RB value as 11.85 kilonewton. By substituting the RB value, we'll get RA value as 22.7 kilonewton. So they asked us to find the resultant force. of the RA. RA is equal to RA x square plus RA y square. For that particular area, it will get that value as 27.2 kilonewton. Thank you.